on this computer. All right, so this was 6A, right? And this is question, oh man, I didn't put the questions there. So we have question number 3 here, number 4. Oh, let me make it less thick. All right, there we go. 3, 4, 5, and 6. Now, you got to read these questions carefully and you guys start thinking of them. It requires a little bit of imagination. So a fair dice is thrown once. So how many times are we throwing it? The random variable X is related to the number N thrown on the dice as follows. So do I have space on the side? All right, on the bottom. So number 3. If N is even, so if N is even, then X is half. So if N is 2, 4, and 6, X is 1, 2, 3. Otherwise, X is double. So if N is 1, 3, 5, you would either get an X of 2, 6, or 10. Okay. Tabulate the probability distribution of X. So what I would do is I would first tabulate my probability distribution for N. Once I do that, then I reference that to X. So what do I mean? Here is N. Here's probability of N. Right? So now, let me give you some space there. I mean, does it make sense what I just said right now? Yeah. All right, so let's do that. You know, I could do it like this. I gotta get caught. The temperature is better, right, on the room? I'm so cold. Okay, I sent the email again today. Like yesterday was comfortable. It really was. But today it's cold again, so I had to open up the windows and allow moisture to come into class so we can have mold infestation. All right. So what are the possibilities we get for N? We get a 1, a 2, a 3, a 4, a 5, or a 6. Now, what's the probability of getting 1 when I roll a die? Everything's 1 out of 6, right? Yeah. All right, so I've just tabulated that one. Now, when we do X and P's of X. For X, we can get the following values. We can get 1. We can get 2. We can get 3. We can get 6 and 10. Notice that there's less potential results you can get from there. Now, 1, how many times does 1 happen? 1. So what's the probability of getting a 2? 1, 6. How about a 2? How many of those happen? You got this guy and this guy. So we're going to have what? 2, 6, right? How about 3? How many times did that happen? Let me do it a little bit different so it looks like I'm trying to be a teacher. So we have 3. No, it only happens once. For X, it only happens once. Oh. You see? It's going to be just 1, 6. How about 6? How many times does that happen? And the last one? And if I add them all up, 3, 4, 5, 6, haven't I just done what the question asked me to do, which was tabulate the probability distribution of X? And that's it. That's all it was. You got it, right? Because I know you started and you wrote it, and I'm like, you wrote an equation for it, and an algebra equation for it. I'm like, yeah, he's on the right path, but did you then simplify it? I mean, I just, yeah, no, I changed it. Okay. So when it says tabulate, you're literally just a little thing. Yes. Wow. And that's it? And that's it. So you're telling me that I was doing the probability of N given X for no reason? Yeah, this has nothing to do with it. I know you're like, get at your points, like done. Yeah, that's it. That's it. Life is so hard when you understand. When you don't, it's kind of sad. Well, guess what? Most of our life, we're not we don't understand why we're here, do we?
I guess not.
So, but we still live life, do we?
Yeah.
But are we content with it? Do we understand it?
I think it depends on the person.
You think somebody has understanding?
I think some people do, I think others don't, like toddlers.
No, wait a second. So you, how about I challenge the assumption that even adults have an understanding of life?
I feel like some adults have, some don't. I think some are facing a false sense.
Find me one. Find me one. Find me one adult that knows.
That knows what?
That understands
Understand what?
life.
Life? My brother.
Your brother? How?
My
What
brother
did?
does 30 minutes last year. He was 45 actually. My brother's awesome. My brother's like 30.
What does he practice?
He does revenue management for Carnival.
I don't care what he does.
That's what you just said. That's what you just
What does he
said.
practice? You said he understands life.
What do you mean? He practices meditation. He practices meditation, clean eating, mental toughness.
Okay.
Yeah, literally a hippie.
Okay. And why is he doing revenue for Carnival?
Because he likes money. He's like one of those stock bros that's really
All right.
only talks about crypto when he comes over.
Tell him to stop.
No, honestly, I told him, I asked him if we could just print more money. He didn't talk to me for a week.
And then when you realize money, like ask the birds if they care about money, or ask God if he cares about money. Oh, that's right. You don't believe in God. All right. Two fair dice are thrown simultaneously. Okay, maybe not true. I'm just saying.
The probability that you.
Two fair dice are thrown simultaneously. The random variable H is the highest common factor of the two scores. Oh, okay, think. Okay, I got it. No, I don't. The random variable H is the highest common factor of the two scores. Okay, got it. Tabulate the probability distribution of H, combining together all the possible ways of obtaining the same value. Okay, so let's, all right, so how does this one work? Do you guys want to try it before I just do it? All right, let me set you up. Let me set you up though. Let me set you up. So Victoria, look, when I roll two dice, I can get a 1 and a 1. And let me make the marker a little bit thinner. A 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, and a 1 and a 6, right? You know the whole thing, right? All right, so now I'm just gonna write it out because I'm forced to, because oh man, I skipped the whole number. I'll just erase it all. 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So now we look at this and we say, okay, the random variable H is the highest common factor of the two scores. So look at the first one, 1, 1. What's the highest common factor between those two? How about 1, 2? Well, 2 would be. Oh, so 1, right? The next one? The next one? The next one? The next one? Good. How about the next one? Well, 2 and 1, which is the highest common factor? 1. Now, what I mean by this, and guys, there's talking, and let me tell you exactly what I'm saying, what I'm thinking. You have some people who are talking that have A's in the class, but you have some people that are talking that you could tell they've given up. But when push comes to shove, you have people abdicating for their grade, and it's like, I know they're not trying. So it's better you just get a pass and go to somewhere else. I'll pass you. We'll see. That's exactly what I'm thinking. And you know who I'm talking to. All right, so 2, 2 is what? Was it 2? So just to be clear, so if you look at 2, 2, you do the factors for it. There's a factor of 1, there's a factor of 2. And this one, there's a factor of 1, there's a factor of 2. The greatest common factor is this. If you had 4 and 8, the greatest common factor is 4. It's what they're divisible by. All right, 2 and 3, it's what? 1. 2 and 4. 2. 2 and 5. 1. 2 and 6. 2, yeah. 3 and 1. 1. I mean, it's boring, right? Can I just continue this and just fill it all out and then we tabulate it? Or do you want to finish it? Well, you already know what's going to happen. It doesn't matter. Like, I'm not going to make you any small. You know what? I can't ever make you any smarter. But does it make sense what I'm doing? So does the homework seem that difficult? It was super easy. You just needed the right push, the right, like, imagination, right? And so 3, 2 is what? 1, 3, 3, 3, 4, 3, 5, 3, 6. Yes, you guys are smart. 1, 4. Just tell me what to write. Last one. That right there, I just wrote. This is what you're going to tabulate now. How do you tabulate it? Well, where is it?
Above the
Where?
2.
So where? Which column? Oh, so which is the 2? This guy. Okay, so that would have made everything wrong. Yeah, because 6 and 4 are the highest. Okay, so now we have H and probability of H. So what are the possible answers? A 1, a 2, a 3, a 4, a 5, and a 6. So how many ones do we have? So now we have to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 23 out of what? You counted 24? Let me. All right, I missed one.
4.
Let's go back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I got 23 again.
What math am I doing? Oh, it's for the 36. I'm saying out of 36.
Yeah, 23 divided by 36, out of 36. How many 2s do we have? 1, 2, 3, 4, 5, 6, 7. 7 out of 36. 3, 1, 2, 3. 3 out of 36.
Just 1 4.
1 4, un 4, 1 4,
5
and 1 5, and 1 6. And this is, by the way, we always check what are we thinking when we do this probability distribution? That the probabilities have to be between 1 and 0, and the sum of the probabilities has to equal to what? 36 out of 36. 23 plus 7 is 30. Plus 3 more is 33. Plus 1 plus 2, 36 out of 36, we're good. Now, some of you might want to reduce whatever you can reduce there, but do we get it? All right. Do you want to, let me look at the next one, number 5, because can you do this one? Try it on your own. Those of you who attempted, did you do it? All right. So for some reason, Josue has like gone from like being like a student I'm yelling at to like a student that's doing homework and everything. And he told me the reason he did that is because he started from scratch in probability and before he was in ACE. It's funny how people are motivated. We are all people, aren't we? All right, guys. You want to try it on your own? Do you want to try it? Do you want to try it? Do you want to try it?
I'm too cold to try. But I will try it
In your cerebro. Okay. Cerebro means brain, right? Okay.
When I went home, I'm excited to do that. It's like a puzzle.
Well, you know what? But
so weird.
But no, let me tell you something. That's the way you learn math. Like you become obsessed with it. You see the beauty of it. Now, here's the problem. You always have some cynic say something about there's other things that are more important, like everything else. But here's the thing. Here's the thing. Any of this math that has been developed by people that have been obsessed about it, and we are the benefactors of it. between math and science, we're like all you have this stuff that we're using right now, this technology and all this is just fancy math being done over and over based on Boolean algebra and logic. That's it. Well, yes, there's engineering involved with like how a transistor. Well, the engineering involved is how can you represent the logic gates and be able to do useful things with it. But it's all just math, specifically Boolean algebra. And of course, you have it's all the same thing, really. It really is. It really is. Okay, so let's look at number 5. When a four-sided die, and then it's just okay, yeah, all right. Can I read it? Okay, when a four-sided dice is thrown, the score is the number on the bottom face. Okay, 2 fair four-sided dice, each with faces numbers 1 to 4, are thrown simultaneously. The random variable m is the product of the 2 scores multiplied together. Tabulate the probability distribution of m, combining together all possible ways of obtaining the same value. Okay, so very straightforward question. Please try and do it. I'm gonna pause the recording and then we'll rehearse it together. All right, so let's go ahead and do number 5. And after I'm done with 5 and then 6, we're gonna go ahead and move on to the next part of the section and hopefully do some problems with respect to that. But basically, when you do this, when a four-sided dice is thrown, well, okay. So you're gonna get results as follows. So I'll go ahead and write it here, number 5. You can get 1, 1, or maybe a 1 and a 2, a 1 and a 3, a 1 and a 4. Or a 2 and a 1, a 2 and a 2, a 2 and a 3, a 2 and a 4. A 3 and a 1, 3, 2, 3, 3, 3, 4. 4, 1, 4, 2, 4, 3, 4, 4. Those are the results you can get. Now, if m is a result of multiplying the 2 scores together, then obviously those of you who know your timetables, 1 times 1 is 1, 1 times 2 is 2, 3 and 4. I'll just write it out. There's no reason for me to be so pedantic. Right? 3, 6, 9, 12, 4, 8, 12, 16. Now, we're going to go ahead and tabulate this. There's 16 results there. So for m, I guess the product or multiplication, whatever, it doesn't matter. M. We have m and we have p's of m, the probability of m. So you have 1, 2, 3, 4, 6, 8, and of course I'm going to run into space issues because this is my life. You know what? Oops. Yeah. Let me go ahead and do it just horizontal. I'm going to do it horizontally, guys. So here's m. Here's p's of m. You can tabulate it horizontally if you prefer. So you have 1, 2, 3, 4, 6, 8, 9, 12, and 16. And now 1 happens how many times?
Wait, you said you moved over to the right.
Yeah, you could, yeah. No problem. So you have 1 happen once. How many times does 2 happen? 2 out of 16. How about 3?
2,
How about 4?
3. What, 3? Oh, yeah, 3. My bad.
It is 3. How about the next one? 6,
2.
8,
2.
9,
1.
12,
2.
and the last one.
1.
Does it add up to 16 over 16?
Yep.
All right. Now, the last one here, a bag contains 6 red and 3 green. 2 counters are drawn from the bag. So for number 6, a bag contains 6 red and 3 green counters. 2 counters are drawn from the bag without replacement. Okay. Tabulate the probability distribution of the number of green counters obtained. Okay, so this one's interesting. Let's go through it together. Or do you want to try it on your own first? What confused you about it? Okay, let's think about it together. So I'm gonna go ahead and drag this way. Okay, so we can still see the question. And let's work on it together. Because when I read it, I'm like, okay, what do they, I mean, I know what they want. It's just like, do I have to be clever or is it straightforward? So that's my worry. Are they like, is it a gotcha question or is it like whatever? So I guess I'll do this in a serious color. See, rainbow, okay, rainbow it is. So let's do it in rainbow. A bag contains 6 red and 3 green crowns. Okay, so I'm gonna, just because I'm gonna draw a bag here. Yes, I am. Here's red. How many reds do we have? And let me pick the green here. How many greens do we have? So how many do we have in total? Now, let's talk about the results we can have. So we're drawing 2 counters without replacement. So can we draw a red and a green? Can we draw a red and a red? How about a green and a red? How about a green and a green? Okay, good. All right, so let's say.
So what do you think of another red and red?
Okay, so
Why I got
those are all the possible results. There's nothing else you can get. So let's count the greens. For the first one, for the first result we have, how many green counters do we have? How about for the second one? How for the third one? And the last one? So those are the potential results. Now, what's the probability of the first one, of this guy here? What would be that probability? So let's see. So the probability of red and green must equal what?
Well, the amount of times it happens 3 times.
Yeah, it can happen 3 times out of.
It'd be probability of red times the probability of green given red, because it was without replacement, right? So what's the probability of getting a red on the first draw? 6 out of 9. Now we have how many tokens left? 8. What's the probability I will get a green? So it's 18 out of 72. So this is 18 out of 72. Got it? What's the probability of red and red? Well, let's see. The probability of red times the probability of red given red. Probability of red is 6 out of 9. Probability of another red given you got a red is 5 out of 8. That's 30 out of 72. Got it? How about when you do probability of green given, probability of green and red? It's going to be, I'll go ahead and write it over here on the left. So this one points to this. Let's go ahead and do this one. Probability of green, and you don't see it. Can I drag it a little bit closer? Yeah, I'll drag it a little bit closer. The probability of green and red. Well, it's the probability of green times the probability of red given green. What's the probability of green? 3 out of? What's the probability of red given I just got the green? It's 18 out of 72, just like the first one. Go ahead.
Why in the red given green, like at the OG one, why is it 8? Even now it makes it over 8 and not 9.
Because I kept it without replacement.
Got it.
If you replace it with 6.
Yeah, but you guys see it, right?
Yeah.
And the last one, probability of green and green. So this one will be this one. Is the probability of green times the probability of green given green. The probability of green is what? 6 out of 9. And then it'll be 5 out of? Oh, 3, that's green. 3 out of 9. Divide times 2 out of 8. That comes out to 6 out of 72. Now we're almost done. Now just make sure it adds up to 72. 18 plus 18 is 36. 36 plus 30 is 66 plus 6 more, 72 out of 72. So we're good. The probabilities add up, but we want to clean this up a little bit, right? So if I were you, and let's do this one in rainbow. The result here is 0, 1, and 2, like that. And we have probability of X, where you have 30 out of 72. And then 36 out of 72. Well, obviously you reduce that, and 6 out of 72. And you can reduce it. And you can't see that, but I'll go ahead and scroll it out. And so that is, in a nutshell, that's the homework. Right? Is that difficult? I don't think it is. I don't think it is. But I'm going to continue recording. The reason I'm going to do that is because I can go ahead and very quickly finish up this section. And that's it. We'll be done with the section. And then I will have a very important assignment for you to do next class. Okay.
Also, any performers, please head down to the rotunda. Thank you.
Okay, wonderful people who are going to leave. Okay, so let's wait for them to leave because
Have a good one.
you two take care, stay alive. Okay, so now we're going to do, and I'll put this on YouTube.
I'm done with it, right?
YouTube. All right, so let's continue with this. So this was a 6A. If you really want to understand this, you have to practice it. So now I'm going to scroll down like here. Be careful.
I will try my best.
Look at the stuff that you missed.
Okay.
Bye-bye. All right, so we're going to continue now. And let me zoom in here. We're here in the middle. Okay. So we know two rules. We know that. So this is notes, continuation. And this goes on to do 6B and 6C. On 6B and 6C. So we know the probabilities have to be between 1 and 0. And we know that we add up all the probabilities has to equal to 1. The question is, are we clever enough to represent them? So that's pretty easy and straightforward to understand. How do we apply it? Well, the application is quite straightforward. So I'm going to go straight to the actual homework questions of this. And they might give you something like on page 106. Let me pick one that looks interesting. None of them are interesting. Like number 3. And for number 3, it says we have X and we have the probability of X equals to D. 0, D, 1.2, 2.15, 3.2, 4.2 D. And so you're supposed to find D. Could you find D? How would you find D there? What will you do? What will you do? Nicole, what will you do to find D? Well, that would not, I mean, what do you know about P's of X? What do we know about P's of X? Tell me 2 things you would know. There's 2 things I've mentioned. There's 1 and there's 2. What will you do? Well, just think about it. What do you think this here has to add up to? 1. So if you take D plus 0.2 plus 0.15 plus 0.2 plus 2D, what does it equal to? 1. So 2D plus D is 3D. So you do divide at some point, but that's not the point. The setup was the initial thing that you needed to do. 0.2 plus 0.2 is 0.4 plus 0.15 is 0.55. And then equals to 1. And then you have 3D equals to 0.45. And you divide by 3. So what's 0.45 divided by 3? It's some number. Let's find out. 0.45 divided by 3. That's 0.15, which makes sense. And that's D. Is that a difficult question to do? The answer, it's not. It is not a difficult question. It's a very easy question to do. Now, obviously, I'm not going to give you the easy question to do for homework because that would be a shame. I'm going to give you the hard questions for homework. And I expect it to be done. Now, section 6C talks about, I guess I can scroll this up. And you can probably go to assigning homework very soon. It says here, using a probability distribution as a model, whatever. As it basically says, it gives us one set of notes here. So this is section, so here you could say this is 6B in a nutshell. I wrote there 6C would start around here. So it says relative frequency equals frequency divided by total frequency, which is approximately the probability. That's their main thing that they're stating there, which makes sense. Now, there's nothing interesting happening there. It is what it is, right? Now, if you want to get the frequency, you would just say that it's approximately the total frequency times the probability. And this is what the big deal they're trying to make about this. So I'm trying to see a question here, which is appropriate. It says here, and it's better that I copy and paste it. So let me do that first. Maybe my book is open. I'll just copy and paste it here. And then we'll be done with 6C. And I'll give you your homework, class success homework assignment, which I'm going to be like, giving you a grade for. Because I feel like you guys need a grade. Besides the easy grades I give you. And again, guys, I can't force you to study, you know? So you got, you know, or do well, but whatever. It is what it is. Not worried about it at all. So let me see. Here's the questions. All right, so there's a nice question here I want to go over, but I think it's too advanced. It's not that it's advanced. It's just we might miss the whole point of this if I give it to you. Let's just do the simple one first. So I'm going to grab it from 6C and we're going to do it together. Make it a little bit bigger. All right, so there's the question. Do we need that? Yeah, I'll leave it there. So it says there are cars chosen at random from a pack and replaced. So are we putting it back in the stack? That's what replace means. The experiment is carried out 520 times. State the expected number of times on which the card is a club. So what's the probability of a club? How much? There's one club. How many clubs do we have? 13 clubs. Remember, you have a 2 of clubs, a 3 of clubs, a 4 up to 10. You have a J, a Q, a K, and an A of clubs. That makes 13. 13 out of 52. But if you carry this experiment out 520 times, how many clubs would you expect? The answer is that the frequency is going to be approximately your total frequency. So the total, or N, times the probability. Now, we've seen that, well, we haven't seen that. We're gonna see that soon for a binomial distribution. But let's just leave it as probability there. So that's gonna be, we did it 520 times 13 divided by 52. So 520 times 13 divided by 52, 130. So you expect approximately 130. So you'll get 130 clubs. You'll get 130 hearts, spades, or diamonds. Now, there's no guarantee on this, obviously, but that's what we expect over the long run. Over the long run, that's what you expect. All right. An ace. Well, what's the probability? So this is part A. What's the probability of an ace? It's 4 out of 52. So if you take 520 and multiply by 4 out of 52, right? Wouldn't you get to 520 times 4? You can see the result already, what it should be, right? It's 40. 520 divided by 52 is 10. 10 times 4 is 40. So do you understand how this question works? Does that make sense? All right. So here's what I want you to do. Your homework, and I'll write it here. Your homework is page 108, 1 through 5, all miscellaneous exercise 6. They're tough. It's right there. You can't miss it. You can't miss it. It is challenging, but it's doable. And then next class we start binomial distribution. So that's what I want you to start working on in class. Those of you who refuse to work in class, maybe this will be the first week I give you an F on participation week. Participation grade, remember that grade again? Can you imagine you getting an F on that one? I've always given you A's. And I won't be shy about it because I don't